In this video, I'm going to show you how to compare different data sets whenever they are both normally distributed. In this example, one student took the ACT and another student took the SAT, and we need to determine which student did better on their respective exam. Student A took the ACT and scored a 29 on the math section. The ACT math section is scored out of 36 points and is normally distributed with a mean of 21 and a standard deviation of 4.8. Student B took the SAT and scored a 680 on the math section. The SAT math section is scored out of 800 points and is normally distributed with a mean of 516 and a standard deviation of 93. So because the ACT is scored out of 36 points and the SAT is scored out of 800 points, it's really difficult for us to determine who did better because the scores are such different values. Now, since both sets of data are normally distributed, I've already drawn a normal bell-shaped curve for the ACT scores and the SAT scores. It will be helpful if we can plot each student's score on the normal curve for their exam and see which score is farther above the mean. So whichever scores farther to the right on the curve would be the student that did better on their exam. So let's start by labeling the normal curve for the ACT scores with the information that we know. We know that the ACT scores have a mean of 21, and since normal distributions always have the mean exactly in the center, I'm going to label the center tick mark with a 21. We also know that the standard deviation is 4.8. We know whenever we have a normal curve, we can add the standard deviation to label the tick marks to the right of the mean, and we can subtract the standard deviation to label the tick marks to the left of the mean. So I'm going to go ahead and do that. 21 plus 4.8 gives me 25.8. 25.8 plus 4.8 gives me 30.6. And 30.6 plus 4.8 gives me 35.4. Now, to go to the left, I'm going to subtract my standard deviation from the mean. 21 minus 4.8 gives me 16.2. 16.2 minus 4.8 gives me 11.4. And 11.4 minus 4.8 gives me 6.6. All right, now let's go ahead and label the student A's score on the curve. Student A got a 29 on the math section, which is very close to 30, but a little below 30. So I'm going to go ahead and label student A's score as a 29. So we can see that they did pretty well. They're definitely above the mean. They're pretty far to the right. Now let's see where student B's score falls on the SAT curve. So we need to label the SAT curve with the information we know. We know the mean is 516, so I'll label the middle tick mark with a 516, and the standard deviation is 93. So I'm going to go ahead and add the standard deviation to my mean in order to label my tick marks to the right. So 516 plus 93 gives me 609. 609 plus 93 gives me 702. And 702 plus 93 gives me 795. Now I'm going to subtract my standard deviation from the mean to label the tick marks to the left. 516 minus 93 gives me 423. 423 minus 93 gives me 330. And 330 minus 93 gives me 237. Now let's go ahead and label student B's score on the SAT curve. The student B got a 680, which is a little below 702. So student B's score was a 680. Now, as you can see, student B's score is also to the right of the mean, so it's higher than the mean, pretty close to the right side. If we try and compare where each student's score is on the curve, as you can see, they're very, very close. It's pretty much impossible to tell just by looking at where each score is on the curve who did better. So we need to take another step to figure out which student did better on their exam. To help us get a more exact idea of where each student's score falls, it will be helpful to find the z-score for each of their scores. Now remember, the z-score tells us the number of standard deviations above the mean each data point is. So whichever student has a higher z-score, that means their score is farther above the mean and therefore better than the other student's score. So let's go ahead and find the z-scores for each student. So to find the z-score for student A, we have to take the data point we're interested in, which is student A's score, which is a 29, subtract the mean, which is 21, and divide by the standard deviation, which is 4.8. So in my calculator, I'll do 29 minus 21, and then divide by 4.8. That gives me 1.67. We always round to the hundreds place for z-scores. Now for student B, So that tells us that student A's score is 1.67 standard deviations above the mean. So let's figure out the z-score for student B. So for student B, their score was a 680. I need to subtract the mean, which is 516, and divide by the standard deviation, which is 93. So in my calculator, I'll do 680 minus 516 and divide by 93. That gives me 1.76 if I round to the hundredths place. So that tells me that student B's score is 1.76 standard deviations above the mean. Now, as you can see, 1.76 is bigger than 1.67, which means student B's score is more standard deviations above the mean than student A's score. So that means that student B did better on the SAT than student A did on the ACT. All right, we have another problem here. In this example, student B decides to retake the SAT to try and improve their score. After practicing the math section many times, their practice exam scores follow a normal distribution with a mean of 690 and a standard deviation of 9. They hire a tutor to review their practice exams with them. So below we have some questions about the probability of the score of the exam that the tutor chooses when they're going to review the exams. So to figure this out, we need to, once again, label our normal curve with the information we know about the student's SAT practice exams. Now, you might be thinking, oh, we already made a normal curve for SATs. That normal curve represented all of the SAT scores of all students, whereas this situation is just about student B's practice SAT exams. So we just want to take a look at the normal curve for the SAT practice exams. So we know that the mean for their exams was a 690. So I'm going to label the middle tick mark with a 690. And then we know that the standard deviation is 9. So I'm going to add 9 to label my tick marks to the right. So I get 699, then I get 708, and then I get 717. Now to go to the left, I'm going to subtract 9. So I get 681, and then I get 672, and then I get 663. So my first question is, what is the probability that the tutor randomly chooses a practice exam with a score below 700? Well, first, let me find out where is 700 on my curve. Well, it's a little above 699, very close, but a little above. This is the score of 700. And I want to know the probability that they choose a practice exam below 700. So that means I'm looking for the percentage of the students' practice exams that are to the left of 700 under this curve. Now, this should remind you of z-scores and the z-score table. We know that we can find the z-score for 700, and then if we look it up in the z-score table, it will tell us the percentage or the area under the curve to the left of 700. So I'm going to start by finding the z-score for 700. So I take the data point 700, subtract the mean, which is 690, and divide by the standard deviation, which is 9. So I'll do that on my calculator, 700 minus 690, and then divide by 9. That gives me 1.11. Now I'm going to go ahead to my z-score table, and I need to find 1.11 in my z-score table. So I'm going to go to my positive z-score table. On the left side, I'm going to look for 1.1 up to the hundredths place. And then on the top, I'm going to look for the hundredths place of 0.01 to match up with the z-score that we found. So I have 1.1 on the left, and then I'm going to look for 1.01 at the top. So I see 0.01 at the top, and then I just need to find the score, the number that corresponds with both of these, and that's 0.8665. So remember, in the z-score table, it gives us the area under the curve to the left. So this gave us 0.8665. Now the only thing I need to do is convert this to a percentage, which I can do by moving my decimal 2 to the right. That gives me, there's an 86.65% chance that the tutor chooses a practice exam with a score below 700. The next question says, what is the probability that the tutor randomly chooses a practice exam with a score above 700? Now for this, we already know the percentage below 700 is 86.65%. So that means the percentage to the right of 700 is going to be 100 minus 86.65%. So all I have to do is take 100%, subtract 86.65%, And in my calculator, that will give me the percent of exams, practice exams, that were above 700. So that gives me 13.35% chance that the tutor chooses an exam above a score of 700. Now the next question says, what is the probability that the tutor randomly chooses a practice exam with a score between 700 and 720? So what we're looking for now is we have 700. We already found that right here, a little above 699. And then 720, it's past 717. So I'm looking for the percentage of the practice exams that are in this green shaded area. So in order to do this, I am going to need to start by finding the z-score for 720. So here's 720, and the z-score for 720 will allow me to find the area or percentage to the left of 720 from my z-score table. Now, obviously, that's not our answer because that gives us way more than just the green section. So in order to get just the green section, then I'm going to go ahead and subtract the area to the left of 700. If I subtract that out, that red section, that will leave me with the green section I'm looking for. So I already have the z-score for 700, and I already know that there is 86.65% to the left of 700. So I just need to find the z-score for 720. So the z-score for 720, I'm going to do 720 minus the mean of 690 divided by the standard deviation of 9. So 720 minus 690 divided by 9 gives me 3.33. So now I just need to go to my z-score table, go to the positive side. I'm looking for 3.3 on the left side, which is all the way down at the bottom, and then a 0.03 at the top, and then I just need to find where they connect, which is going to be right here at 0.9996. So if I go back, I'm going to write that I got 0.9996, which I know as a percentage is 99.96%. Now all I have to do, as we discussed, that gives me a really big section to the left of 720. I need to subtract the purple section or the red bracket to the left of 700. So that's 86.65%. So I'm going to take 99.96% and subtract 86.65%. And I'll do that in my calculator. 99.96 minus 86.65. That gives me 13.31% as the probability that they choose an exam between 700 and 720.